I'm a junior urban designer at Skidmore, Owings & Merrill in Chicago. You're Doing It Wrong is a tutorial series that I started when I was in college. And the reason I did that was because everyone came to me when they needed help with everything. And I also had to get my work done. So I started this tutorial series to basically dump what I've learned over the past 7 years of architecture school and a first year of professional work, and have this be a resource for people to use to learn at their own pace. So yes, You're Doing It Wrong is a little tongue-in-cheek, but it has a very serious mission of showing people how they could actually go about working with the software and learning it better, so they don't have to fight the software, but use the software to get design skills done. So again, You're Doing It Wrong is a tutorial series. It's meant to help people work smarter, not harder, so they can get to design. You feel free to follow us on on all social media at YDIW, You're Doing It Wrong, _series on all social, and that includes YouTube. So I'm also part of the NOMA Professional Development Committee, so I actually run monthly sessions there. But I believe that a designer should be versed in all tools available to him or her, so they're never bottlenecked by the lack of knowledge of any specific tool. So today we're going to be talking about Rhino and Grasshopper, but I've got videos on Photoshop, Illustrator, InDesign, GIS, Revit, Dynamo, Premiere Pro, After Effects, and the whole gamut. So stay tuned for a lot of those videos are coming soon, but there are some that are already available on the YouTube channel today. So this is the roadmap that we've been working on this year. We've covered Photoshop, Rhino, Grasshopper, InDesign, Illustrator, Revit, Dynamo, Enscape, and Lumion. GIS I moved to later this month after the conference that we're in now. So that's coming later this month. Premiere Pro and After Effects is November, then Bluebeam, and then we will reset the year, probably do something else. Still working on that new roadmap. So in today's session, we're going to be learning about parametric workflows, how to use Grasshopper in Rhino to actually start working parametrically. And that means that you can start linking certain things together and working a little bit more efficiently in your daily workflow. So primarily the programs in this session will be Grasshopper and Rhino. There are two main file types that we as designers work with. And the reason why I go through the presentation at the beginning is to set fundamentals. A lot of times when people jump into tutorials, they jump into them and then you're lost for the entire tutorial. So I don't typically work that way. I always set groundwork for what you're going to be seeing later on. So that also starts with understanding fundamentally what are the tools that you use on a daily basis. So the two main graphic tools that designers use are raster files and vector files. Rasters are pixels, which are little squares of color information. And when you get enough of those together, they can compose an image. So every screen that you've ever seen is composed of pixels. Pixels are limited. So if you lose pixels, you can never gain them back. Your resolution is typically fixed. So the higher you start, the better for your end goal or process. Vector files are different, and that's what we'll be working with today. Vector files are mathematically generated by your computer, which means they are in fact infinitely scalable. So there's an advantage to vector files, but they are more computationally advanced. So just note that the more vectors you have, the harder your computer has to work to process that imagery. And of course, we are all aware of the almighty DWG file format. Every respectable program in architecture uses DWG files. That includes Illustrator. So you can bring in your DWGs into Illustrator and do things with that. So those are the types of things that I want to make sure that people are aware of in the tutorial series that I've been running. Okay, what is a vector? The reason why I'm going through this is it will be very important when we get to Grasshopper at fundamentally understanding what vectors are composed of so you can manipulate them later. So mathematically, a vector has a magnitude, which is a length, and a direction. It could also be defined by a connection between 2 points. Points are the simplest form of information. They have 3 coordinates, x, y, and z, if you're thinking three-dimensionally. But they're either a length and a direction or a connection between 2 points. Now in Rhino, vectors are generated like this. They start in 3 major stages, and when you understand these 3 major stages, you can pretty much do whatever you want three-dimensionally. So the first stage is the point, right? So X, Y, and Z, all geometry has point information in it. Then you get curves, which is what Rhino calls lines. And it's kind of like squares or rectangles, but rectangles aren't squares. curves are lines, but lines aren't necessarily curves, if that makes sense, and I'll talk about that later. But a curve, the simplest curve is a connection between 2 points, but in NURBS geometry, which is what Rhino uses, every curve or line that you see is actually an infinite extrusion of points. What that means is that you can extract a point from any location along that line, and that will come in handy when you're working in Grasshopper and telling a computer, I need you to do this here at this point by this much. So every curve that you see is an infinite extrusion of points. A surface is the same thing. Every surface is an infinite extrusion of curves in both directions, in the U direction and the V direction, which is just what Rhino calls the X and Y of an object. And that also means that a surface is also an infinite extrusion of points. So you can extract a point from any location along that surface. That will also come in handy. And then you get meshes. Meshes are either 3-face or 4-face objects. They're a little different in Rhino, so you typically don't work that much with meshes, but just note that meshes are computationally easier for computers to compute. So every video game and CGI graphic you've seen in movies are composed of mesh geometry, just because they're easier to manipulate. Okay, degrees. So every curve has degrees in Rhino. 1 degree curve is a line. A 2 degree curve has the ability to be curved. So the more degrees that you have, the more levels of curvature you can add to a curve. Okay, so what does parametric mean? Parametric is often said alongside coding, algorithms, scripting, computational design, visual programming. These are all synonyms that mean that parametric design is basically objects are related to each other. So when a change happens on this side, that same change is reflected throughout the process and affects everything together. So you often think about parametric, oh, that's a parametric building. You often think of something that's really funky with a lot of curves and a lot of lines here and there. And well, I want to actually bring that down to the more practical level. What can you use parametric design for on a daily basis that will help you? Examples being, if you wanted to calculate the GFA of every building in your design, you could do that using parametric design instantly and have a script that does that automatically. So instead of you doing the exact same steps over and over again, every time the design changes over and over again, you have a tool that's automatically doing that. So those are the types of things that help people work faster and save time, which is really important when time equals money. So we'll be talking more about that in a little bit. The type of parametric design or visual programming that Grasshopper uses is called node-based logic. And that means that instead of learning lines of code, which is what almost 90% of coding is lines of code that has a very high learning curve, node-based coding allows designers to skip that learning curve and get to the power of coding without actually learning how to code. But the thinking is still the same, and you'll see a lot of places where I'm like, okay, I want to do this, so I need to set that up here. And so node-based coding, which is what you see at the top, is an easier form and saves you a lot of time. And actually, when you get good at node-based coding, it makes learning how to code in linear code a lot easier because you're using the same thinking process when you do that. Okay, so Grasshopper is a plugin for Rhino. It comes baked in with Rhino 6, but if you're using Rhino 5 or older, you do have to download Grasshopper as a plugin. It's free, as in most plugins are for Rhino, which is awesome. But you need Rhino in order to use Grasshopper. Grasshopper is not a standalone program. Okay, if you understand what I'm about to tell you, you will fundamentally understand scripting and you'll be able to build your own scripts. So all scripting and coding has 3 major steps. You have your input, which is the data, which is what you're manipulating, so the what. You have the command that runs an action on your input, and then it spits out an output. Very simple. And what scripting allows you to do is turn your outputs into inputs for new scripts. So you can start linking together your workflow. It's basically like when a teacher says, how did you get to that answer in a math problem? Show me your work. Scripting allows you to show the work of the workflow you got, so you can see where I started and where I ended up at the exact same time, and you can make changes along the way. So that's the power of scripting, and if you understand this, again, you will be able to do a lot with scripting in your daily practice. So advantages of and understanding parametric design. It's used for 3D modeling, node-based coding, parametric design, form generation, form finding, and a lot of different things. But I'll show you some examples of how that can be very useful when we get to the tutorial portion. So another portion that's really important is that it does take a long time to build a script that works and works well consistently. So a lot of the times, people are like, oh, I can just do that manually and it will be done. But you have to do that manually every time you have to do it. Or you can spend that exact same amount of time in the front end building the script that then saves you a ton of time later on. So at the beginning, it is very slow and it takes time. But once you have the script built, it's infrastructure or a framework that you can use later. So it becomes very fast. Okay, so any piece of geometry, like I said earlier, you can extract information from it. So you can extract points from curves, or you can extract surfaces from 3D objects, and then grab points from that surface, and then use those points to do something else. So any geometry that you see and work with in Rhino, you can extract information from and work with that information. So for example, this 3D object, if I wanted to get the area, I could get that. But that area also requires a set of calculations that give you a center point. And that center point you can then use to, for example, get the normal of the surface, or attach a column to that surface, or place an important object on that location on the surface. So there's a lot of things that you can connect using information that comes inherently in the objects that you're working with. Okay, so we'll get into this a lot, but what you're basically doing in Grasshopper is you're manipulating data. You're moving data from one location to another. You're changing it here, you're changing it there, you're taking information out, you're adding information in, and all of that comes in lists or structures of information. So what that means is that every point that you make a modification creates a new tree or a portion of the list that then creates a new structure. So what that means, so let's say we're starting with this initial object right here. Let's say we exploded it into its 6 faces. We've now created a new tree where it's referencing the first object, but now we've got the 6 faces in a separate list. And let's say we grab one of those surfaces and split it into 4 or 5, 1, 2, 3, 4, 5 different pieces, right? We now have the original object, the 6 faces, and then the 5 divisions that we've made on that surface. And so understanding list structure will really help you when you're manipulating your scripts, right? So if you want your original object and the 6 faces that you've created, if you want changes that you've made up here to interact with these, you need to do a process that's called grafting, which will bring that down a list structure so it will be able to interact better. And you'll see why that's important. I just want to make sure that you're understanding what we're doing here. So each one of these processes creates an addition to the tree. And so you'll see why that's really important. But everything is, you're basically just moving data around. And when you understand that, you can then say, okay, I need this to interact with this, and I can take the proper steps to do that. Okay, so we'll talk about plugins, and then we will get into an example, a very simple example where you can see what we're doing, and then we'll actually start building some pretty cool things. So there are lots of plugins that augment the abilities of Grasshopper. For example, Kangaroo adds physics engines to your script. So you can test gravity, you can test structural loads, you can test if you're creating a structural truss, does it work well? So lots of really cool tools that we're not going to get into today, but those tools are available and I just want you to be aware of them. Okay, so a very simple example of how a script works. So we've got an input, right? And that input here is a point. So if you remember our 3 stages, I've created a point in Rhino and I'm saying, Grasshopper, look at this point. And then I'm feeding that point into a component that's called move, right? Because I want to put that point in a different location. Manually, you would click on the point, you would then type in a distance in a certain direction, and you would hit enter and it would be done. But if you wanted to do that process again, you would have to select the point, type in move it again and again. Or you can tell a computer how to do it. So you have the point, you have a command called move. Move requires 2 inputs in order to work properly. It needs to know what it's moving and by how much and in which direction. So in this case, I'm telling Grasshopper, move it in the Z direction, which is vertically, right, by 10 units. And the 10 units uses whatever units Rhino is using. So if it's in feet, it's 10 feet. If it's in meters, it's 10 meters. And then you get the resultant point that's been moved by 10 units. But it hasn't actually physically moved the point. It's created a copy, because you still need the initial input for the output to exist. So that means you have 2 points. And because you have 2 points, you can do, for example, create a line between those 2 points. And then you can use those 2 points for other things. Does that make sense? Okay. So this is what we're going to be building today. It is a tower completely generated in Grasshopper. Again, don't feel like you have to get everything down, but I will go step by step on how I created it so you understand how to work with it. And at each stage saying, oh, that would be really handy in a project I'm working on now. So all of that was generated from 2 curves and 2 panels that represent what's going on in the facade. So we'll be building all of that today. But first, let's do move. So I'm going to type in Grasshopper into Rhino. And I have a lot of plugins, so my Grasshopper takes a little longer to open than most people's. So we'll be patient. Okay. So I'll snap this over here and then snap Rhino to the right so that you'll see them both at the same time. I'm going to place a point at the 0, 0, 0 location, which is the origin. I'm then going to double click inside Grasshopper. So this is Grasshopper, and this is your canvas. This is where all your scripts will be built. So if I double click, I can then type in point and hit enter. And that point has now been created. It's orange because it has no data. It's basically a warning saying, hey, I don't know what to do at the moment. So that's what orange means. So if I right click on the component, I can go over to set 1 point, or you can set multiple points, but in this case, just 1 point. And then I'll select the point that I've created in Rhino. And now that component has turned gray, which means, hey, I have information and the information is correct. I'm happy. Orange, I have nothing or something is wrong, but it's not fatal. Gray, which means everything's good. And red, which you'll see probably in a little bit, which means something is critically wrong and I can't work properly. So we want to avoid reds at all costs. But we now have the input, the what. We are now going to create the command. So in this case, it's move. So I'm going to plug point into geometry. And you'll see that the point has already been moved. It has a default in the Z by 1 unit, I believe. But in this case, we want to be able to control that. So I'm going to create a direction component. In this case, unit Z. But you can also use unit Y or unit X or any other direction that you want. So unit Z. I'm then going to plug that into move. And you can see that it's moved a little bit because this component has also a default value. And if you want to see what the default values are, you can like scroll over and it says by 1. So if I zoom in, maybe that'll be bigger or not. Okay, 0, 0, 1, right? And now I'm going to create a number slider, and there are a few ways to do this. You can either type in number slider, and this is where the parametric power comes in. So when I plug this into unit Z, now Grasshopper knows what to move, in which direction to move, and by how much. So when I move the number slider, you'll see that the point moves as well because it's all parametrically being related, right? And so I have the input point, and on the output side, I've got the new point here. I do like to house components in their own little housing units, right? That way I can move it around, do other things with it. But my new point now lives here, and I've got 2 points. I've got the original point down here, and the new point. So if I wanted to create a line between them, I type in the line component. There are 3 types of line components. There's a reference component, which means there's a line that exists in Rhino. Reference that just like we did with the point. There's a line component that allows you to create a line between 2 points. And then there's a line component that says you only have 1 point, and that's the start. You then give it a direction and a length, right? A magnitude and a direction. Like I said earlier, there are multiple ways to create a vector, right? In this case, we want this component here, and the start point will be our original point, and our end point will be our new point. And now we have a line that automatically connects both of those points, and it moves with the reference points because it is parametric. Okay, does that make sense? Any part of that not make sense? Okay, so let's get a little bit more complex. We're going to build the tower. And in this case, there's a little bit of setup that we have to do to get this working properly. So I'm going to create 2 layers here in Rhino. I'm going to call this layer footprint. And I'm going to create another layer called core. And then let's create those 2 curves in the proper layer. It's very important that you keep your layers organized, please. I've seen many students' files and some professionals' files that are messy. Please don't be them. So I'm going to make this a 100 by 100 foot tower. And I will create the core in the proper layer. I'll create that in the center somewhere. It doesn't really matter at the moment how it looks, but we just need those 2 curves to be created. Now, let's jump into Grasshopper. So one important note about Grasshopper is that anything that you create in Grasshopper doesn't physically exist in Rhino. It's just visually represented. The only way to get Grasshopper geometry into Rhino is doing a process called baking, which then turns it into hard Rhino geometry. But the thing is, it's then broken from the reference. So when you move that new geometry around, it's not affecting the script, and they're not really interacting with each other. It's basically creating a copy again. Okay, so I'm going to create what's called the geometry pipeline. And that just says, hey, Grasshopper, look at this layer. And any changes that happen in this layer reflect that change inside Grasshopper. So it's asking me for a layer. I'm going to name it footprint because that's where my footprint curve is. There are 4 types that you can click on it. There's the point. There's the curve, which is what we're going to use. There's the 3D object, which is called a B-rep, which stands for boundary representation, which is just 3D object or polysurface. And then the last one, which I always forget, which I never use, so we don't worry about it. And then I'll create a copy of this and call this core. So any objects that are in the footprint layer will be automatically put into the script. Any objects that are in the core layer will be automatically placed in core. Okay, so then let's do our first action. We have our initial curve, and what I want to do with that curve is create my floors of the building. So I'm actually going to create a move component like we did earlier. And again, move creates copies. It doesn't move the original, which gives us a lot of opportunities here when we're working with the script. So I'm going to plug my footprint into geometry, but it's only moved it once, right? I want this to be a tower, which means multiple floors. Now I could make 50 move components, but that's not as efficient, right? That's going to take a long time, lots of components to manage. Let's work more efficiently. So let's use what's called a series component. And a series component requires a start, a step, and a count. So a start is basically what number am I creating, right? You're creating a list of information that you can use later. And each step, so if I plug in 1 into step, it'll go 0, 1, 2. If I plug in 2 into step, it'll go 0, 2, 4, etc. And then how many should this list be, or how long should this list be? So in this case, we're going to leave start at 0. The default here is 0. But the step is going to be the number of floors. So let's make this number slider potentially go up to 100. So when you type in a number straight up, it just creates a number slider that goes to that number, which is much faster than creating number slider, going into its settings, and changing its variables. So this represents our floors, and I can actually rename number sliders to floors, which will make it easier for me to understand what that number slider is doing. So I will plug 100 into step. Start, again, is default 0, which is where we want it to be. But if we didn't want it to be that, if we wanted our floors to start at a different height, we can have start at 10 feet. And now we've got, or whatever, and we've got a different variable for the start than the end. So in that case, I'll just create a number slider there and leave it at 0, which will do the same thing, but we might want to play with that later. So This is thinking ahead. Like, I have an idea of where I want to go, and that's really important with scripting. It's hard to build a script where you don't know where you're planning on ending, which is why when you're learning Grasshopper, I often would download scripts that have already been made, intentionally break them, and rebuild them myself so I learned what each component was doing. It's the best way to learn. And then counts. So counts, let's see, it's stepping, right now, actually, sorry, this is going to be stepping by 100 feet. That's not what we want. Let's say 10 feet. And then the count is the number of floors. So this is floor height. Floor height. And we'll just leave that labeled. We'll leave that, we'll call it second plus. Okay, so I've now got a list here. And if you want to see what's inside a component, you create what's called a panel. And I will create that panel. And I'll plug series into the panel. And now you can see a list of numbers that have been created based on the series. It starts at 0, and it goes up by 10 feet each time. And so when I plug this number into Z, it will create 10 curves that are 10 feet apart, right? Now, all computers do this. This is very confusing, so you have to understand this. All computer lists start at 0. So you can see here it says 9, but because of 0, it's 10 values. So just note that all lists start at 0. So that's just an important point to note. Okay, so we will then create a unit Z, plug our series of numbers into unit Z, and then our factor into motion. And we now have 10 floors that are 10 feet apart that are referenced from the original curve, right? And we can play with that value, right? So if we want the floor heights to be higher, we can do that. If we want more floors to be there, we can do that. So let's say we want 50 floors. They're all 12 feet apart. Very simple, very easy. You've got it already made. And then you can do really cool things, like rotate each floor by 15 degrees as it's going up, or make each floor expand as it's going up. So start small and end big when it gets up, right? And these are all working parametrically. So as you change numbers, all of those changes you've built in will also be reflected. We'll keep it simple for now, though. Do you have a question? Okay. If you have any questions, please feel free to stop me. I forgot to mention that at the beginning. Feel free to stop me if something doesn't make sense. Okay, so from here, we're going to create our floors, and then we're going to create the geometry that will house our facade. So what we're going to do here is we're going to create the floor surfaces. So I'm creating a surface component. Actually, it needs to be a boundary surface. What boundary surface does is it takes a series of closed curves and it creates a surface in them. Very simple. So we'll plug our floors into boundary surface, and now each one of those floors has a surface. We will then take these surfaces and extrude them down by a foot, which creates our floor thickness. So we'll type in extrude. And again, these are all the same commands you use already, right? We're just telling Grasshopper, here's how I want you to use them. And I want these to go down in the unit Z. And I'll create a number slider that goes from 0 to 5, which is the thickest possible floor I can think of, but I'm sure there are thicker floors than 5 feet. So we'll create a number slider that goes to 5. To do that, you hit 0, and then the greater than symbol, and then 5. And that'll create a number slider that goes from 0 to 5. And then we will create a negative component. You could go into the number slider settings by double-clicking and then changing the minimum value to -5. But that's a whole step. It's just easier to create a negative component. Any number you plug into it will become negative. So I'll plug in 5 into this, and then plug this new number, which is -5, into unit Z. And then I'll change it to something more reasonable, like 2. So now each floor is 2 feet thick. And again, all of these changes will be reflected when you make changes to earlier portions in the process. So back to 12. And right now you're seeing everything visualized, which gets really messy. So it's important to sometimes unpreview things. They're still working. So if I select these, right click, I can turn their preview off. So not everything is not layered on top of each other, because again, you're not changing things, you're making copies. That's really important to understand. Okay, so we've got our floors here. I'm going to label these as floors so I have them for later. So we'll call this floors. And now I know this is where my floors live. I'm done with floors, basically. What I want to do now is create the actual tower geometry itself using the original floor curves and have those linked together. So I'll create that by using what's called a loft command. If you've used Rhino, you're familiar with what loft is. We're not going to use this geometry, though. We're going to go all the way back to our original curves. So I can go ahead and plug multiple things from an output, right? So I'll plug curves into loft, and now you can see my facade geometry has been created. If I turn off the preview for everything, you can then see there's that geometry. And again, that geometry is tied to the number of floors we have, so everything changes together. So in urban design and planning at SOM, this is typically what we get to. And from here, we can generate FAR, we can generate GFA, we can generate a number of different values that we can use later on. And we can make changes on the fly. Okay. So from here, what I'm actually going to do is take a step back and look at the core. Let's not forget the core. Now, what I can do is the same process, but that's a lot of steps, and we don't actually have to go through that many steps to get to a similar result. We want the core to be just as high as the tower is, and I don't even want to have to worry about the core. I want the core to automatically change with everything else. I could give the core a separate value, but then I would have to go back and change that value manually. Let's not worry about that. Let's tie everything together here. So I'm going to grab this guy. I'm going to create a surface, just like I did earlier. So boundary surface. I'll plug the core geometry in here, and I'll unpreview everything so you can see what we're working on. So there's our little surface there. I'm going to extrude it upwards. So extrude, unit Z. Plug that into here, and plug the base into here. Now, can anyone tell me how I'm going to link both the floors and the core together so they're always the same height? So I need to extract information, right? Information that's embedded inside the geometry. So what I'm going to do is grab the height of the topmost floor and plug that number into the extrusion for the core. So they'll always be the same. Does that make sense? Okay, so here's how to do that. So again, all of the information in Grasshopper is just data, right? It's data that you're basically just moving around and manipulating, right? So this list of curves here that represent my floors, the topmost floor is number 50, which is the 49th in the list, but it starts at 0. So the 50th curve, which is the topmost curve, I want the Z information or the height information from that curve. So what I'll do is tell Grasshopper, give me that curve alone, and then I'll get the area of the curve, right? So I'm going to type in what's called a list item, plug that list, which is just the list of data, from the floors into the list here. And then you can see each item has a number associated to it, which is the order of its list. So I'm going to type in 49, and that number will then be fed into the list and give me the 49th curve. Or, shortcut, pro tip, if you type in, so I could either link in this number here into item, but because of the oddities of computers that starts counting at 0, there is no 50th curve. There's a 49th curve, right? So I can go into the list or index, go to expression and say x minus 1, which will then say any number I plug into here, subtract 1 from that number, and that'll give me 49, or whatever number I tell it to be when I move the number slider. Or if that number slider doesn't exist because of a different workflow that you're using, you can tell it to always give you the last number in the list by typing in -1. It's just how it works. But -1 in the index will always give you the last number in the list. So you don't have to worry about it ever again. So this is the top curve, and it will always give you the top curve. I'm then going to type in area. And area is a really cool component because it does give me the numerical area of that curve, right? So if I type in a plugin here, it's 10,000 square feet. Great, I have that information. I don't need it now, but it's there. But what it also gives me is the center point of that curve. And that center point I can extract for its x, y, and z data. So I'm going to type in deconstruct point, right? So I have a point, and it's going to give me its x data, its y data, and its z data. You can also construct a point by plugging in an x, y, and z, and that'll give you a point. So you can go in either direction. So now I have the height of the topmost floor. And again, I'm going through all of this, so I never have to worry about it again. So it's 558 feet tall. I then plug, so let's go ahead and grab all of this here, move it down here, because Grasshopper always reads from left to right, so I like keeping the script nice and clean. So I'll move this up here so I can always see that height later on. So if I need to know what's the height of that tower, just look at that panel component and I'm done. I'll then plug Z into factor. And now my core will always be as tall as all of the floors will be. So if I change the number of floors, you'll see that the core will also change with them. So that is now a parametric relationship between two geometry. All right. So now what we'll do is we'll then create our panels that will then be layered on this facade of the building. So from here, what I'm going to do is do what's called a deconstruct. So like we deconstructed the point, we gave it a point and it gave us its x, y, and z. We're going to do the same for the B-rep, the boundary representation of the facade. So we'll type in deconstruct B-rep. And that will give us its resultant faces. So 6 faces, top, bottom, and then all 4 sides. Its edges, so if we just wanted the curves, we can get those curves, or its vertices, the points that are on each of the edges, right? And then again, you can use all of that data for different things. In this case, we just want the faces. There's 6 of them. And just so I know which number each face is, there's a little handy trick here. Use an area component to get the center point of each face. And then you create what's called a point list component. And that gives you a visual number for where a point exists on the list. So if I make this big, you'll see this number up here on top of each surface. So I now know that that surface is 0, that surface is 1, 2, 3. This will help me determine what face I'm working on later. And because the lists are the same, right, it's referencing previous geometry, I know that the faces will also be the same for each one. So I can rely on that data connection I'm getting between the two. Okay, so from here, I can then tell Grasshopper, give me the 0th surface, please, which is just a weird thing to say, which is just the same way of saying, give me the first surface that I want to work on here. So that surface. The default is 0, so it automatically gives me the surface, but I'm going to create a number slider that goes from 0 to 6 because I have 6 faces, right? And then I'm going to plug that into index, and that's good. And the reason I'm doing this now is because I'm going to copy this process and paste it 4 times for the 4 faces. So I'm going to construct it once, and it's done, and then I'll copy it and link it together and just change one value to give me a different face. So I have that face. Now what I'm going to do is subdivide it into the floors and use information from earlier on to link them together. So divide domain squared. So that says, give me a domain, which in this case is actually going to be our surface, because a surface is composed of u and v directions. Now what I'm going to say is divide the surface in one direction by 1 and the other direction by the number of floors that I have. So it's often hard to determine which one is which, so usually just trial and error works here. And in order to see what you're doing, so let me hide everything else really quick so it's not all overlapping. So we're just focused on this surface here. And then I'll just create a number slider really quickly. And then a component called isotrim. Where's it? Isocurve, no. Isotrim. Here we go. Which will then visualize what I'm doing here, so it makes sense. Okay. So I've got the U and V in the incorrect direction. It's dividing it 100 times in the vertical. So I'll just flip the numbers here. Oh, that was a mistake. I should have unplugged it. One sec. We'll let that think. And then plug 1 into here. So there we go. So the U count is the count I want to modify. And if I zoom out here, you'll see that it's been divided 100 times. Again, I could control it manually myself, but I want to tie it to something else that's happening earlier on so I never have to worry about it again. So instead of plugging in 100 here, I'm going to go all the way back to the number of floors and plug that number. So go all the way back and tie that number into, let's zoom in. It's hard to do both at the same time. Into U, and I'll just delete this because I no longer need it. Now let's see if the floors I just created and the divisions match. So let's turn on the previews of everything here. So floors. It's kind of hard to see, but let's go over here. Okay, so it's close, but it's a little off. So let's make sure that it's working properly here. So what I might actually have to do is subtract 1 from the value. So I'm going to go over to uCount and type in the expression x minus 1, which will take 1 away from the number. Okay. And that's lined it up perfectly to the top face. Can you see it? Hope you can. Okay, actually what I'm going to do is turn off these guys. Okay, much better. So now you can't see any of the divisions because you can also see the floors as well. But so now I've got the proper number of divisions for the floors. So let's hide the floors, or for the facade. And now what I'm going to do is take this and create my panels, right? So the panels that will be placed on the facade. So I'm actually going to create those manually in Grasshopper, in Rhino. So I'm going to grab the box component, and I'm actually going to create 2 new layers. We'll call this panel A. And then we'll create a panel B. If I can spell it. I'll just duplicate that and call it B. And then we'll just create it. And it doesn't really matter what size you make these because it will automatically modify them to be the correct size on the facade. So I'm just going to create 2 rectangles here. And that will be my solid panel. And then I also need to make sure that's on the right layer. That's going to be important. So we'll make sure that's on panel A and panel B. And then I'm going to cut out this will be my glass panel. So I'll take that curve, I'll offset it by, what's a typical mullion thickness? Throw a number out there. 2.5 inches. Okay. That actually might be too small to be visual. So let's make it 6, and you'll see why I'm making it big now in a second. So 6 inches. Okay. I'll then use the wire cut command, which if you don't know about is probably one of the best commands in Rhino, which just makes trimming breps with curves a lot easier. So now I can, wait, did I finish it? I don't think I did. No. Let's do that again. Sorry. 1, 2, 3. Keep all, yes. Enter. And then I can just delete the center. Okay, so it's just an empty mullion object, and that's all we need for now for the visual. But you can have more complex panels that have detail in them for later purposes. But we'll keep it simple for processing purposes, because I don't want us to be here forever. And I'm sure you don't either. Okay, so there are our floors. We've got our panels made. Let's make sure they're on the right layer, which always important. And then like I did earlier, I'm gonna go back and just copy these guys and call this panel A. And then change its type to brep, which is what it's referencing. And then the same for panel B. Okay. And we'll move these over here so they're closer to the action. I'm then going to subdivide each one of these floor faces. So if you look at the list structure here, we're actually quite far in the list structure. We're 4 trees in, right? We have our initial rectangular shape. We then take one of those faces, which creates the second tree. The third tree is the divisions that we have here, right? So just to keep you in note of where we are in the tree cycle. All right, we'll create a surface box. What it does is it takes a domain and the initial surface and creates a height. And that height will then extrude it outwards to give it thickness and give us a division. So we'll plug in our initial surface here. Should be here. Plug in our domain. And then a thickness. So let's say we want our facade to be 3 feet thick. Okay, so I made a mistake. This goes in there. And here we'll actually, this is where we'll actually create the vertical dimensions to it. Okay, there we go. Sorry about that. Okay, so there are panel dimensions. We can make it more or less based on what result we want. So let's say we wanted 20, or number slide that goes to 20. That might be a lot though, so let's stick with 10 for now. Okay, so we've got our, basically our boxes that represent each place or location along the facade. From here, we're then going to link the panels that we created down here with the new surface box dimensions. So we're going to reference our 2 objects here, and then we're going to plug those into a box morph. So if you look at our original panels here, we'll bring in panel A. And then we'll say, I'll actually create a brep. How's that here? This is our geometry. And what it's saying is, okay, you have my geometry. Give me a bounding box for that geometry, and then I'll morph that original bounding box to the one that's on the facade and place it. So I'll create a bounding box here. Bounding box. So take this brep, give me its bounding box, which is exactly the same since it's a very simple shape. But if you had, for example, a sphere, the bounding box looks like that. So it would take that bounding box and morph it, right? But in this case, we're just working with a rectangle. This is our reference bounding box, and then we'll give it our new bounding box, which is here. And so what it'll do is it'll take that shape and then align it with all of the various areas. Let's use panel B so you can visually see. This panel A is also solid. but there's panel B. It's going to take a little bit longer since it's a slightly more complex shape, but there it is. So if I hide everything else, we now have got our facade definition. And again, all of this will change if I change the floor. We've gotten pretty far along, so I'm not going to do that. But just, of course, you know that it will change as well. So if the client's like, actually, 50 floors is too much, let's go 40. Instead of you having to restart every single process in modeling, just change the number and bake. Done. Okay. So we'll make this panel A. Now what we want to do actually is create some variation, right? That's pretty much a pretty blank, boring 80s facade. So let's say we wanted to pixelate it a little bit and use some combinations of panel A and some combinations of panel B. So we can actually play with which surface boxes we use to then be mapped to A and which ones we want to be mapped to B. You can do this in pretty much any way you can think of. You can randomly select. You can create a true false where it's true, false. So true would represent panel A and false will represent panel B, which is what we're going to do. You can say, okay, select every third and make that panel A, and it'll do that. So there's a bunch of different ways. Any way you can imagine, you can script it and tell the computer to do it. So in this case, we're just going to do a simple true false. I'm going to create a panel here that has the word true and then the word false inside it. So we'll go in true and then false. And then I'm going to actually type in false again. So it'll go true, false, false, true, false, false, true, false, false, true. And it'll just repeat. So I don't have to type it multiple times. It's just saying, okay, once the list is done, I'll start over from the beginning of the list. So let's make that big. So true is 0, false 1, false 2, true, false, false, true, false, false. And I'll plug that into a dispatch component. Now what dispatch does is it takes a list. So if I zoom in here, it takes an initial list. It takes a pattern, which in this case is true, false, false, and then and splits the list up into its respective places. So list A will be all the trues, and list B will be all the falses. So true, false will be plugged into pattern, and my list is actually my initial boxes here. And then I'll create, just so you can see the visual, we'll plug in box. So these are now my panel A's, and these are my panel B's. So we'll just hide these so we don't see them. And then instead of plugging in the initial all twisted boxes, we'll plug in the new. We'll do panel B, which is the glass, and we'll make the solid the other one. So if we wanted to keep that 40% number, which is good for sustainability, we can control that. So we could do 40% of the objects, make those panel A, and the other 60% panel B. So you can get into some real detail here that meets code and other sustainability metrics. Okay, so that's panel. Okay, so we'll create another one. And instead of linking panel B, we will link panel A and plug that into geometry. Oh, actually, sorry. We need our bounding box reference, so we'll plug that there. And plug B into target. Okay. So let's label this so things aren't as confusing. So what I'll do is I'll go in here, create a group, and once you create a group, you can create names. And super fast, this is kind of like just a me being OCD thing. The default colors for the panel is yellow, and it's gross, and so I changed it to white. So to do that, just right-click color, which is spelled with a U because it's this Grasshopper is designed by an Austrian coder. Anyway, so default color, you can change it to white, then set it as default. Same thing with the group color. Anyway, besides the point, I'm going to call this glass, and we're getting towards the end here. And then we can start asking some questions, and then call this solid. And so now I know which one is which. And then I can move on to the other faces. So I finished one face, but because I've already built it, I don't have to build it again. I can just copy and paste it. So the start here is, okay, right here. And I'm gonna move this over here so you can see a clear division between the two. And the panels I'm gonna leave up here, and I'm not going to include them because I want them to be the same. And then I'm going to make a bigger group here and call this south face, so I know which one it is. Always label, because it makes your life easier later on when you come back to a script that you haven't used in 3 months and you're like, oh crap, I can't remember. So anyway, so there's that, and so now I'm gonna take that and copy it. And I'm gonna turn off the solver. So Grasshopper, any changes you make automatically run. If you don't want that to happen so you can make a lot of changes without it thinking every time, just disable the solver so you'll see that red pop up. And now I can just copy this and super fast and then change the values and then let it run. So that's just another pro tip for saving time later on. So copy, paste. Paste. All right, so there are 4 faces. Of course, if you had an L-shaped building, you would have 8 faces. So you'd create more. So that's 0. We'll change this to 1. We'll change this to 2. We'll change this to 3. And then let's make any modifications we want now before we go forward. So if we're looking at this, we're gonna want more shading protection on the south, east, and west face. And then the north is not as important. So I'll actually make the north all glass. And then I'll customize what goes on the east and west and leave south as is. So in order to do that, we can say, okay, the 2 face, which in this case, I can't remember which one was 2. Actually, no, it was 0, 1, 2. So 1 is the west face. So let's say we wanted more solids there. Let's turn these off so it's not processing until I'm done. Disable. And turn on the solver. Okay, so this is south. We'll change this name to west, because that's what it is. North, which will make all glass. And then east. Oh, is there 2 of them there? Okay. We'll worry about that later. Okay, so my west facade. Reduce. This will be fast. Reduce domain or reduce list. Random reduce. Okay, so what that'll do is it'll take a list, and then I know I have how many boxes in this list. I have 490 boxes. I'm going to divide those by a percentage, and a percentage is just a fraction, right? So if I wanted to get a particular percentage, I could either type it in, or I could make a number slider and a division component. So let's say I wanted it to, 1 over, or actually, let's make that go to 10. 10 over 10. Let's say that's 1/4. If I leave that at, that's 1/4. Okay. 0.2. So let's say, okay, so I want 0.2 of the number of boxes. So the boxes here, if I type in list length, there's 490 in here, but I need that number as an actual number that I can plug into something else. So when I plug that into list length, it will give me the number 490. And then I need, a percentage of the number 490. So we'll do a multiplication between these two. Does what I'm doing make sense? So I created the number 1/4, which I'm sure there's an easier way I could do 1/4. If you're gonna be like stickler about it, we could do 1/4, which will give me the 4th. Right? Or is my math wrong? 0.25, right. And then I'll plug that into multiplication, and that'll give me a new number, which is 129.5. I need an integer, So we'll round that up to the nearest number. So I'll plug that into integer here. 123, that's good enough. So it's going to take the list of boxes and randomly reduce them by a quarter. So now I can say, okay, I've got these. Let me get the other ones. So I'm sorry, this is getting a little bit more complex, but this will be cool. Okay, so let's say we created set. Actually need list index times 2, and then the original boxes are over here. And I'll explain what this is in a second once it's done. So what I'm doing is cross-referencing the original list with the reduced list to give me the remaining, because I need 2 lists. So right now I've got a list of a quarter, but I need the other ones. So that's what I'm doing super fast. So I'm referencing those. And then I will put those into a list item. Set difference. And I'll also make this particular script available so you can play with it, break it, and learn basically how to integrate it into your workflow and how to build your own. Because that's, honestly, it's the best way to learn. And that's how I learned, was I took scripts that someone already made and then I broke it and then fixed it. Okay, so those are remaining. So we've got the random reduce and then the remaining. So now we've got our 2 lists. We can plug those in and get our paneling surfaces. There are also, I mean, if you're like me, you'll think, oh, there's so many cool things I can do. Let's say I wanted it to be based on solar radiation, and that would give me the split of lists. Or if I wanted that to be based on the amount of shading that would be plugged in. So you would create a script that analyzes shading and plug that into your factor that would then give you your 2 lists. So you can go really far here with just thinking about, okay, I've got this set of data. How do I make that set of data work with what I'm working with? So the graph function is giving me domain. That doesn't necessarily give me 2 lists unless I plug in the right data, which I can't think of right now. But think about what those factors could be. So I'm going to hide all these. But now I've got my 2 lists. So I'm going to plug these into panel B, which is my glass. So instead of... I'll plug that into target instead of this guy. So sorry, this is getting a little messy. But I would then, after I've made it, go back and clean it up after the fact. But this is usually what it looks like when you're making things from the start. Actually, this should be solid, and this one should be glass. So if you're wondering why stuff over here still works, it's because to Grasshopper, it's still reading left to right, even though I've got it on the right side. Okay, and if I wanted to just do glass on the north face, that's just taking all of them and plugging those into target here, and then just leaving the solid disabled so it doesn't think. And then I'll leave east as is, so let's go ahead and turn these back on. Actually, except for that one. Enable. We'll wait for a sec. Go grab a cup of coffee, some water, snack. And then we'll turn on our preview. Again, lots of time in the setup at the beginning, but once you've got it made, you can change it to whatever you want later on. So if the building needs to get bigger because the client just got a new donor and now they've got more money in the development project, you don't have to go through the process of building everything again. So that's why this helps with your workflow. So I encourage people to start thinking about Rhino and Grasshopper again. I know our industry has moved strongly towards Revit. Dynamo pretty much can do everything that I just did here. So Dynamo is the Grasshopper of Revit. And I actually did a series on Dynamo, which I'll be uploading soon. But a lot of the same concepts apply for Dynamo as well. So don't forget about that as an option that you can use for for Revit to do the same thing. But in my opinion, Grasshopper is just more flexible. It has a lot more tools available to it. It's less buggy, so I just prefer it. So it's hard to see right now because everything is red. And if you want to actually start visually seeing what it might look like before you bake, again, none of this geometry exists inside Rhino. It's all virtual until I bake it. But I still want to see what it looks like before I do that. So I'm going to create a custom preview component. And if I zoom in here, you'll see it. And then I'll create a swatch, which will give it a color. So let's say white. I haven't even done structure yet. I wanted to show you that. It's really cool. We'll do that super fast. It'll be the last thing we do. And I'm going to create what's called a merge component. You can plug multiple things into an input, but you have to hold shift to do that. Well, sometimes you just don't want to have to go through that. You only want to plug in one thing once. So I'll create a merge component here. And then all of my solid components, I'll plug into merge. So I'll go down here, plug this guy into merge. And you can start seeing it turning white. That solid is turned off, and then we'll plug that into merge here. Okay, so there it is. Okay, so those are my mullions. All right, and then I'll create another one that's slightly grayer, and we'll make that our solid panels. So I'll unattach all those super fast, and then reattach the new ones. I think I might have mislabeled these. Oops. Okay. Okay, there's the glass. I forgot to plug that into here. And then I'll unpreview all of these. And unpreview the merges, which also shows a visual. All right. So there is our building. Sort of. Those are all solids, but you get the point. So from here, we can then say, okay, cool. Let's turn our floors back on and give those a visual. So I'll actually copy these components. We'll make the floors white. And then we'll do structure super fast, and then we'll be done. So if you remember, our floors are way back over here. And from here, I'll plug that into here. And now our floors are there. I'm going to turn off the preview for the loft, which is somewhere over here. So I'll just mass unpreview and then preview these back on. So there are our floors. I'll do the same thing for the core. I'll make the core also white. Core extrusion. Okay, so there's our core. Oh, there's an extra curve there. Goodbye. Oh, I actually didn't hit delete. Okay, never mind. That's why we were waiting. Oh, it was auto-saving. Okay. There we go. Okay. All right, so we've got our core, which you can see inside. So if we go inside, let's do that real quick. Actually, real quick. I'm going to create a floor, a ground. Ground. This will make zooming much easier for me. I'm then going to hit ZSA, which resets the zooming, which allows me to zoom more freely. So ZSA, super handy. So you can see our core in the center. And now we're going to do our columns really quickly, and then we'll be done with this tutorial. So columns, let's hide everything. And let's go back to our original curve. What I'm going to do is create another boundary surface. So this will be a different process, right? So this process was for our floors. So I can label that. actually, this was the core. And these were our floors. And now we're going to work with our columns. So I'll create this surface here, and I'm going to divide this surface. And each one of those points will now represent a column. We don't need that many points, so I'll go in and customize the numbers. There is a process where you can say, I want these to be 30 feet apart, and that just takes the U dimension and divide it by 30, so that gives you, it'll give you the number of dimensions you have to plug, or divisions you have to plug in. That's all. I'll just give you the original script I had, and that has that in it, since we don't have a lot of time. So that's 100 by 100. Let's reduce that by a lot, and also reduce the U. Okay, that's a lot of columns. So let's say 3 by 3. In this case, it's 100 by 100, so this should be pretty clean. Let's move our core a little bit. Again, literally just 4 pieces of geometry and an entire tower. And I have a script that will generate everything. Okay. All right, so there's where our columns will be. I don't want the columns to show on the outside. It's kind of ugly. I mean, Mies made it look good, but you know, I'm not Mies. So I'm going to offset the original curve. And if I hold a Shift Alt, I can change the input to another and then plug that new curve in here. And you can see it's already being offset by value. So if you look at the points, it's now a little outside. I want it to go inside. So I'll plug in a negative and give it a number like, let's say, offset it by 3 feet. Let's see what 5 looks like. Okay, that's a little better, right? So it takes that new curve and use that curve instead. Does that make sense? So you can go back and change how inputs are working. Okay, I'm going to create a rectangle. And sometimes it's good to just go in and grab scripts that have already been built. So for example, when you create a rectangle component, it creates the rectangle from it, and then it goes out like that when I want the column to actually be generated from the center. So I didn't know how to do that before, and I looked online and I found a script that someone else had already built for generating a center rectangle. So I just copy it, paste it into my new script every time I need it. So I've got like a repository of really handy scripts that other people have built that I can just grab and plug in. So this guy right here will give you a center rectangle from a point. So I'll copy that and paste it in. And it always pastes in its original location, so it's way over here. So I'll now plug these points into here of that rectangle, and now I've got my center-based columns. Cool. I can determine the width of each. So let's say 2 by 2. Boom. And just like the core, I'll attach its Z height to the top surface, and then I'm done, pretty much, with the columns. So I don't have to create all of that again. I can just copy from here and then plug rectangles into base and leave the Z alone, and it's done. So there are my columns. And then I'll plug my columns into that same preview, that white preview. All right, and then turn the preview on. And the building is pretty much done. So yes, it took me an hour and a half. Did I take an hour and a half? Wow. No, just an hour. No, yep, hour and a half. But I've now completely saved a week's worth of work later on. And now I've got places where I can make changes. So I know that, oh, the client doesn't want that much of a certain material. So I can go back, change those values, generate a new geometry, and bake it. Any questions? Yes?
Are you familiar with Scratch?
With what?
Scratch?
Scratch?
The children's like, programming
Okay, so I'm not really familiar with it, but I know I've seen examples of children programming languages which allow children to start thinking algorithmically without like going super deep, but when you start getting kids interested in that early, it's really cool. But yeah, is it developed by Google or someone?
I'm not sure. It's pretty old, but I have it's very reminiscent of it, and I feel like it's a good.
It's node based. Yeah. Which simplifies. To code this manually would take a long time if you were really good at it. But with this process done, I now have all of the respective elements. Let me show you baking really fast, and then we'll be done. So let's say to bake, you always create a new layer. Always, please, always create a new layer, please. So we'll call this floors, a new layer, when you bake geometry. Because if you don't like it, you can just delete the layer and you're done. If you bake it to the layer that you're already using, then you have to go in and select them all. It's a mess. Don't do that. Don't work that way. So the geometry for floors is over here. This guy, I'll just right click, hit bake, select the layer called floor. And now that's real Rhino geometry that I can then do things with, right? So that's pretty much the whole process. I hope you learned something. If you're used Grasshopper 4, I hope like something was new. If you haven't, it's a lot of fun. Get into it, especially if you're a student, because you've got a ton of time. You can like watch a ton of tutorials like mine and really understand, okay, here's how I can use this in Studio when the professor's like, give me 50 iterations by Wednesday, and it's Monday. Oh my gosh, you can just say, okay, 40%, 50%, 60%, done. So that did that a lot. But anyway, again, the links to the videos that already exist, again, I've got hours and hours of content. If you type in, again, YDIW _series, you can find me on all social. This link right here takes you to my website that goes into more information. So this is kind of like the master hub for all things you're doing it wrong. So definitely check those out, subscribe, like, all that stuff. More videos to come. Again, GIS later this month, Premiere Pro and After Effects November, and then Bluebeam December, and then I'll figure out what the next roadmap is for sessions. Awesome. Thank you guys.